Hello friends, today we will discuss the uh, some part of the fluid kinematics, that is the types of fluid flow. Uh, Different types of fluid flow are steady and unsteady flow, then uniform and non-uniform flow. Third one is the laminar and the turbulent flow. Fourth one is the rotational, irrotational flow. Then depending on compressibility, compressible and incompressible flow, and with respect to dimensions, one dimensional, two dimensional and three dimensional flow. Now let us discuss all these fluid flow one by one in detail. Now starting with the steady and unsteady flow. The steady flow means a flow in which the fluid characteristics like velocity, pressure, then density, etc. at a point do not changes with respect to the time. And thus in the case mathematically you can say that del V by del T is equal to 0, del P by del T is equal to 0, then del rho by del T is equal to 0. Example of a steady flow is the flow with the constant discharge to the pipe. Then a flow in which the fluid characteristics like velocity, pressure and density at a point changes with respect to the time, then it is unsteady flow. That means mathematically del V by del T is not equal to 0, del P by del T is not equal to 0 and del rho by del T is not equal to 0. The example is the flow with a varying discharge through the pipeline. This is the steady and unsteady flow. Then the uniform and non-uniform flow, a flow in which particularly the velocity at a given time do not changes with respect to the space, that is particularly the length in the direction of flow, then it is called as treated as a uniform flow. That means mathematically del V by del S is equal to 0. The example is a flow through the long straight pipe of a uniform diameter. Then a flow in which a velocity at a given time changes with respect to the space, that is the length in the direction of flow, is non-uniform flow. Mathematically we can say that del V by del S is not equal to 0. The example we can quote a flow through the long straight pipe of a varying diameter. These are the shown here. The diameter is uniform throughout the length and here the diameter is varying along the length. This is the uniform and non-uniform flow. There are the flow combinations usually will get, that is the first one is steady uniform flow, in which conditions do not changes with respect to the position as well as in the stream as well as with respect to the time. That is the example is a flow of water in the pipe of a constant diameter at a constant velocity. Then steady non-uniform. In this condition changes from point to point in the stream but do not changes with respect to the time. That is example is the flow in the tapering pipe with a constant velocity. At a inlet velocity will change as you move along the length of pipe towards the exit. Then the third combination is unsteady uniform flow. At a given instant in the time conditions at every point are same but will change with respect to the time. For example, a pipe of a constant diameter connected to the pump pumping at a constant rate which is then switch off is the example of a unsteady uniform flow. And the last one is the unsteady non-uniform flow. Every condition of flow may change from point to point and with respect to the time at every point. That is the surface waves in the open channel is the example of unsteady non-uniform flow. Then the third classification of flow is the laminar and turbulent. The flow in the laminations, that is in the layers moving parallel is termed as a laminar flow, while in the case when the fluid flows or fluid flow layers intermixes with each other is termed as a turbulent flow. A laminar flow is the one in which the paths taken by the individual particles do not cross one another and move along the well-defined disciplined manner. A laminar flow has a three conditions. Definitely it have a low velocity, The with the high viscosity, the fluid is of high viscosity, and channel is the in which it flows is relatively small. For example, groundwater flow. Then you can take a blood flow through the veins, or you can take a flow of a sap in the trees, arteries of trees. Then turbulent flow is the flow in which the fluid particles move in the zigzag manner or a haphazard way. And the example is definitely the natural flows, that is the flow of water in the river is the example of a turbulent flow. Then this turbulent and laminar flow, one number, dimensionless number is used to classify these flows. Reynolds number, it is the ratio of inertial force to the viscous force, and it is used to differentiate between the laminar and turbulent flow. And for particularly the pipe flow through the pipe with a diameter d, Reynolds number is defined as rho Vd by mu, in which rho is the density, v is the velocity, and d is diameter, and mu is the dynamic viscosity. And according to this formula, if R is less than 2000, the flow tends to be laminar. If it is more than 4000, flow tends to be turbulent, and if it is in between 2000 to 4000, the flow tends to be in the transition state. This shows the laminar flow to the pipe. This shows the turbulent flow in which they crosses the one another path, and this shows the transition phase between the laminar to turbulent flow. Then the next classification of flow is the compressible and incompressible flow. This compressible flow is that type of flow in which the density of fluid rho or gamma, it changes from point to point, or in other words, the density is not constant for the fluids. Thus the mathematically for the compressible flow, rho is not equal to constant. Whereas for incompressible flow, that is the type of flow in which the density of a fluid is constant for fluid flow. Mathematically for incompressible, rho is equal to constant. Liquids are generally incompressible while gases are the compressible. Then the rotational and irrotational flow. The flow is said to be rotational if individual fluid particles, while moving in the direction of flow, also rotates about their center of mass, that is the flow near the solid boundary. Like this, the example is shown near the solid boundary. It, while moving in the direction of flow, it also moves, it rotates along its own mass, center of mass. Whereas irrotational flow is said to be rotational if the fluid particles, while moving in the direction of flow, do not rotate about their mass center like this. Then this is the rotational flow and irrotational flow. To test whether the flow has a rotational component, you can put a small object in the flow and let the flow carry it, and if small object spins, the flow is rotational, else the flow is irrotational. This figure shows here this object, this fluid particles are not rotating, it is moving in the direction, whereas here the fluid particles are rotating, and this is the rotational flow near the boundary region, solid boundary region. Then the one-dimensional, two-dimensional, three-dimensional flow. Although in general all fluids flow three-dimensionally with a pressure, velocity, and other flow properties varying in all those directions. In many cases, the major changes only occur in the two directions, or even only in the one direction. In these cases, the changes in the other direction can be effectively ignored, while making the analysis much more simple. Flow is one-dimensional if flow parameters such as velocity, pressure, etc. at a given instant in the time only vary in the direction of flow or not across the cross-section. A flow through the small, that is circular pipes of a long circular pipe is the one-dimensional flow, whereas the two-dimensional flow, if it can be assumed that the flow parameters vary in the direction of flow and in one direction at a right angles to that direction, that is the example is the flow, two-dimensional flow over the weir. Then three-dimensional flow, if the flow parameters vary in the all three directions, that is the three-dimensional flow in the Stirling basin. Thank you.